We are now on part 4 of the lab, make your own clouds. So what I've done here, we just have a bowl of water and dry ice. We're trying to do something a little different than the other version of this experiment, where what we've done here is first we're trying to chill the water down to about, we're going to basically try to raise the temperature in about 10-degree increments, and compare what we get as the kind of clouds you get. So we slowly but surely raise the water temperature. Now, the reason the water temperature is going to matter quite a bit for the clouds you get from this is that, in this case, what we're doing is we're using frozen carbon dioxide, aka dry ice, to chill the water down. As a consequence, what a lot of those bubbles you see when you put the dry ice in water are going to be carbon dioxide, which is heavier than nitrogen and oxygen, the two principal components of our atmosphere. However, as you warm up water, you put more water vapor in the atmosphere, and you make the air less dense, and it is going to start to rise. So what you're going to be doing for this assignment is you're going to be taking temperatures off this thermometer here that you'll see in a moment, and then you're going to convert to Kelvin. This is just adding 273 degrees to this. And what we're trying to do is get a robust model for the temperature at which we start to see the clouds actually rise. And your clouds are going to rise when they're lighter than the surrounding air. You'd think that'd be when they're hotter, but because they're made out of carbon dioxide, which is substantially denser than air, they have to get quite a bit hotter than clouds that form from water vapor over oceans and other areas that are wet. So it's not a perfect model, it's in fact an imperfect model, but we can still get many of the major important concepts with it. So all right, let's get to starting here. So what we got here, I'm going to raise my camera just a touch. Try to move it back just a touch. And here is our bowl of water. This is our first stop, and we're just going to directly, you're going to be writing your things on the sheet. You can pause the video at any time. This might also give us a sense of just how accurate or inaccurate our thermometer is. Okay, our bowl is at about 1.5 degrees Celsius. So now we're going to add a little bit of dry ice. We're going to try to add a very small amount and watch the clouds that form from it. Not a lot coming out of here because, well, there's definitely heat being transferred to the dry ice. It's not happening very rapidly, and so we're not getting very big poofy clouds. This is kind of to be expected. Round 2. No. Looks like we're now at about 10.3 degrees Celsius. Hopefully you notice that there is a little bit more cloudiness happening from it now. Yes, this is how it is supposed to be. It should be just a touch more cloudy. Great. Clouds are still sinking, but they are sinking a little bit better. It's now warmer than the air here. It's about 23.5 degrees. So we've gone up about 10 degrees, and now we're going to add a little bit more dry ice to this thing and see what happens. So you can see there's a much bit more vigorous rate. This again has to do a lot with a couple processes happening. The carbon dioxide is under quite a bit of pressure. When the bubble bursts, the bubble depressurizes. That leads to a little bit of cooling of the air in the bubble. And when the air in the bubble cools a little bit, it picks up the water vapor that is also present in the bubble. Round 4, fight. So there we go. So now we got our water is a little bit hotter. Ideally, we're trying to get it to about 33 degrees. We're trying to go up in about increments of 10. Almost 30. 31.9. I think we're going to really call that good enough for now. 31.9. And so if you want to try this out at home, definitely make sure to get your hand in the smoke like I'm doing. It will look, you'll get a better sense of just what's going on here. I will say the smoke still feels cooler than the air around me, which is probably one reason it's sinking. But also, you can see these sort of interesting patterns. You're starting to see a little bit more, clouds are looking a little more curly, they're doing more various other things. All right, so now we got water that's at about 42 degrees. Nice. All right, let's take a look. This water, by the way, is starting to feel pretty warm. And you're starting to see a very different kind of cloud here. This water body here is going to be approximately 51.4 degrees. All right, 51.4 degrees. All right, here we go. 51.4 degree water. So one thing you're noticing is as the water gets hotter, the rate at which we get these clouds gets more and more vigorous. This is to be expected. We're seeing more and more as what's happening is Waters will rapidly transferring heat to the dry ice, creating more vigorous bubbling. We're also seeing the clouds get a little taller. They're still sinking because, again, they're mostly carbon dioxide, but we're starting to see some other things happening here. So this is encouraging. You can also see there's quite a bit of steam rising off this water at this point. Yes, it's going to be right, yep. It's now at 61.8 degrees Celsius. All right, commence the addition of the dry ice here. Oh, there we go, it's working. Oh, we have rising cloud. We have bubbly, poofy cloud, like your cirrus clouds. Ooh, wow. Ah. Our water again at 72 degrees. All right, we're going to say 70.8. And here we go, rising clouds. We have achieved rising clouds at about a little over, right around 71 degrees. In fact, I tried this a little earlier with a smaller piece of dry ice at just slightly warmer temperatures, and the clouds were really rising. So this appears to be the inflection point. So we're somewhere around 70, between 69 and 75 degrees Celsius. Pretty exciting. As the water cools down very quickly due to the latent heat absorption, quickly get a lot less dry ice, but yes. First, we're going to try it with slightly colder. We're going to just try, here we go. Last I checked, this was about 67 degrees. All right, 65, good enough. Yeah, well, there we go. Yeah, it was rising. We have a rising cloud at 67, yes. 65, yes. Actual rising cloud. Intriguingly, what we also notice is that this cloud continues to rise for a much longer time. I'm trying to figure out why that is, but yes, it is. All right. All right, good. It's well above 70. That's good. 83.9 degrees. All right, let's do this. Oh wow, now we have a cloud that rises all the way up to the ceiling of the apartment building. Now very quickly this water will cool down and that cloud will no longer rise. In fact, you can see the height the cloud makes it is directly related to the function of the water temperature. I'm going to be putting together some graphics on this in a little bit, see if I can toy with some equations. There's a couple things for predicting the partial pressure of water vapor in air over body water based on the temperature body of the water body. I'm going to see if we can predict this because I'm starting to be really, really curious. Yes. So I'm not sure exactly how hot this water is, but I'm assuming it's hot. Woo! There we go! Holy smokes. Huh. So you can see it's rising, yeah, very vigorously. This is pretty awesome. Wow. Notice, by the way, how quickly the water, when I put that big chunk in there, it really, oh, yeah, it subsided very quickly. All right, hope this has been fun for everybody. Let's leave this going for a few minutes and then, yeah, call it a day.